All right, guys. So we are doing notes 36. Is this the last set? Yes, last set of notes. Notes 36. Woohoo. And this one is really not that bad. So let's look at it. Here we go. So empirical versus molecular formulas. You, luckily, because you are in regular chemistry, you do not actually have to calculate empirical or molecular formulas. You just have to understand the terms. You have to know what they mean and be able to pick them out. All right, so an empirical formula, let's just say what a chemical formula is. Okay, so I got H2O. That's the chemical formula of water, right? Okay, so if I have an empirical formula, that means it is a formula with the lowest whole number ratio of elements in a compound, meaning it's like it's been reduced, or it's the lowest it could possibly be. So when I look at this example here, this is H2O2. That's hydrogen peroxide. I would think about those subscript numbers, the two twos, and I would think, could I reduce that? Do they divide into each other? Can I reduce those to a lower number? And yes, they both are divisible by 2. If I divide them both by 2, I end up with HO. Okay, so they're like, I need 2 hydrogens and 2 oxygens. Well, they would be the same to say I need 1 hydrogen, 1 oxygen. Now, that's not actually true in real life. In real life, they do need 2 hydrogens and 2 oxygens to make hydrogen peroxide. But the empirical formula is sometimes needed for different calculations, and all it means is it's in its most reduced state. When I look at something like water, H2O, I can't make that divisible, because the 2 I can divide by 2, but I can't divide the 1 by anything, because it has to be a whole number. So H2O is the empirical formula. It's in its lowest whole number ratio right now, but it is also a molecular formula. So it's both. It's in its lowest form, and a molecular formula is a chemical formula that shows the actual number. Like in real life, it is H2O. So it shows the actual number and kinds of atoms in that compound. So sometimes they're both. H2O is the empirical formula, meaning it is in its lowest whole number ratio. I can't reduce it anymore. But it's also its molecular formula, because that is what it is. H2O is its actual number. Okay, so when I'm looking at my little example here, it says H2O2 is the molecular formula. Like, that's what hydrogen peroxide actually is. So molecular is what it actually is in real life. That's what its formula is. Empirical is when I reduce it, if it's in its lowest whole number ratio. So if I look at these examples down here, all you got to think about is, can I reduce it? If I can reduce it, then it's a molecular formula. If I can't reduce it anymore, then it's in its empirical formula. All right, so this one, 4 and a 10. Well, both of those are divisible by 2. So that is not in an empirical formula state, so it is molecular. That's its molecular formula. That must be its real formula in real life, the tetraphosphorus decoxide. All right, next one is a type of sugar. So I'm looking, I got a 5, I got a 12, I got a 1. There isn't a number I can divide all 3 of those by, so that is empirical. That is its lowest form it can be. All right, look at Na2SO3. So I have a 2, I have a 1, and a 3. Well, those are not all divisible by the same number, so that is empirical, sodium sulfate. And lastly, we have S2Cl2, so sulfur, that'd be disulfur dichloride. And those are both divisible by 2. I can divide them both, and it could be SCl. So that is molecular, because it is reducible. And there you go. That really is it. You just have to be able to identify them and be able to read a question and know which one I'm talking about. So empirical means it is in its most reduced state. Molecular means it's its actual compound. All right. One last thing that you have to know how to calculate is percent composition. We're going to do a couple practices with these, and that'll be it. So these are not mole problems, but they kind of help us with mole things later in a later unit. So percent composition goes with it. The formula you need to remember is to get a percent. This is true for how you calculate your grades. Like, you have, what is your grades right now? 30% test grade, 60% daily. That's right. That's wrong. But I would take those percentages and figure out how much of your test grades factor into that, how much your daily grades factor into that, and all of that is a percent. So we actually use percent calculations often, and this is the formula for any percent calculation, including percent composition in chemistry. So you take the part, you divide it by the total. So I guess I'll write it below. So you take the part, divide it by the total, and multiply by 100. And that gets it into a percent form. The part divided by total will be in decimal. It'd be a decimal because it'd be a smaller number divided by a bigger number. Multiplying by 100 moves that decimal over 2 places, making it a percent. Okay, so how you set this up is you're going to write out what you have in the compounds. Right now, I want to find the percent composition of HCl, which is hydrochloric acid. I have one of each of them, so that makes it easy. What you're going to do is you're going to get their mass from the periodic table, and that's going to be our parts divided by the total. So hydrogen on the periodic table, its mass is 1.01. Okay. Chlorine is 35.45. So those are my two parts, but I need to add them up to get my total. So these are my parts. So this will be my part hydrogen. This will be my part chlorine. I'm going to add up to get my total. So I have 35.45 1.01 equals 36.46 is my total. Okay, so what my formula says, it says take your parts, 1.01 and 35.45, and divide them by the total and multiply by 100. So I'm going to divide each of them by 36.46, so that's the total, 36.46. Okay, so we're going to divide those. So I have, and then multiply by 100. But I guess I'll show you that process. So 1.01 times 36.46, and I get, I didn't divide, 1.01 divided by 36.46, and I get 0.0277, okay? And then I will stop there. So I have 35.45 divided by 36.46, and I get 0.9723, and stop there. So again, it's in a decimal, that's not a percent. So to turn this into a percent, you multiply it by 100, and all that does, you don't even actually have to really do it, all multiplying by 100 really does is move the decimal over 2 places. So hop, 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 hop. So it's gonna be 2.77% of this compound mass is hydrogen. So not much of the mass of this compound is hydrogen. Hydrogen is a really small atom. And then 97.23% is chlorine. And if you look at it, if I add up 2.77 to 97.23, they would add up to be 100%. So 100% of the compound, which is what they should do. It might be a little off every now and then by a couple decimal points if you didn't round correctly from the periodic table, but it should be very, very close to 100. All right, let's do the one below it. So now I got a little more complicated one. Al2, SO4 with the 3 outside it, so aluminum sulfate. Again, you're going to write out things that are in your compound, like this. There are 2 of them in aluminum. This 3 goes to sulfur, so there are 3 sulfurs. And 3 times 4, there are 12 oxygens, all right? So when I get their mass, I'm going to have to multiply them by those numbers and then I'm going to add them up to get the total. Let me rewrite that. Let's give myself a little more room down here. Get 12 times oxygen equals, they're going to add them all up and get the total. Okay, so aluminum on the periodic table is 26.98. 26.98, but it's going to be multiplied by 2. And then I'm going to have 3 times sulfur. So sulfur is 32.07. That's being multiplied by 3 because there's 3 of them. And then I have 12 times oxygen. So 16 is what oxygen is times 12. And there we go. And I'm going to add all those up in the calculator. But I actually do need to kind of write out my parts first. So my first part will be 26.98 times 2. And I get 53.96. And then I get 32.07 times 3, and I get 96.21. And then lastly, 16 times 12, I get 192. So those are all my parts. Now I need to add them up and get my total. So 53.99, no, it's 96, plus 96.21 plus 192. And I get 342.17. That's my total molar mass. So we're also calculating, like, this is the molar mass. So at molar mass, it goes with what we've been doing. I have to add up all the mass on the periodic tables. That's the molar mass of aluminum sulfate. So I take the part of aluminum. So aluminum's mass in this compound is 53.96. That's the mass that's coming from aluminum. And I'm going to divide it by the total mass of the overall compound, 342.17, so that I can figure out the overall percentage of the mass that aluminum is taking up in the compound. I need to move my picture. There we go. Okay. And then same thing for these, 342.17 will be divided by 342.17. We'll get answers for those. Then they'll be multiplied by 100, which just moves the decimal over 2 places. So 53.96 divided by 342.17, and I get 0.1577. Then I get 96.21 divided by 342.17, and I get 0.2812. And lastly, 192 divided by 342.17, and I get 0.5611. Okay, now when I multiply these by 100, multiply by 100, multiply by 100, multiply by 100, you know what that really means is move the decimal over 2. That's all it would do in the calculator. So it can save yourself some time of putting it in the calculator. Just move the decimal over 2. So it's going to be 15.77% of this compound is aluminum. 15.77% of the mass is coming from aluminum. 28.12% is coming from sulfur, and 56.11% is coming from oxygen. There we go. Percent of the composition. This is how you figure out if I needed to separate my percent compositions, like I needed to do a chemical reaction that would separate them, and I wanted to know how much mass I would get out of it. This would tell you, because this is how much mass is in it in that compound. Okay, just one more, and then we are done. Oh, determine the percent of CO2 in NaHCO3. You know what? I don't think we need to do that. So for now, I'm going to leave it off. If we do need to do it, I will come in and do a little mini video of it, but I'm pretty sure that we're not actually going to have to calculate that kind of thing. So let's just skip it. If we don't have to do it, then let's not. All right, so that is the end of notes, guys. Woohoo. Make sure you're turning in the whole set, because I'll be grading it at this point. Well, that went by pretty fast.